Okay, Algebra I students, let's learn some exponential growth and exponential decay problems. So we're going to do some graphing today. The first thing I need to tell you about is an exponential function. So the equation is going to look like y equals a times b to the x power. Now the x power belongs to just the b. So what's the a? The a is the coefficient, and b is the base. That's right, base. X is the exponent, or you can say power, and y is the output. Now, if y is the output, you could also say that x is the input. That's where you're going to put the values in, do the calculation, and see what you get out. Now, another name for b, I know b is the base, but that also is going to be our growth rate today. Growth rate. So we are going to be growing as well as decaying. Okay? So let's take a look at the graphs for these two things. The graph on the left is exponential growth. The y values, here's the graph, up, are increasing over time. And I'll use a red pen for this side. Over here, for exponential decay, I notice the graph going like this. The y values are decreasing. So you could have something increasing, like when you put your money in the bank. That's what I hope happens. And then things that are decaying or decreasing over time. The domain for something like this, you can plug in all real numbers from negative infinity, less than x, less than positive infinity. And let's just write a little note here. Okay, when you have two like this, like a sandwich, we always use less than signs. The range, let's take a look at the y values. The graph is completely above the x-axis. That means that the y values are all greater than 0. They're all up there. The growth rate for this is going to be more than 1. If I keep multiplying by 1, my money's not going to grow. For example, y equals 15 to the x power. That number is a growth rate. Now what does decay look like? You're still going to be able to plug in any number you want. All of these x values are being used. So how do we say that, class? You start from negative infinity. What kind of symbol do we use? Less than x, which is less than positive infinity. And how about the range? Is there any graph below the x-axis? No, the range, all the y's are more than 0. What's the equation going to have? A growth rate that is less than 1. For example, I have y equals something less than 1. I know, a half. As time passes, half is left, until it gets really small. Alright, today we're going to be graphing some of these. So here's an example of an equation with a chart. We're going to have to fill that chart out. We have a piece of graph paper, and then we're going to see what kind of graph we get. So the first thing we're going to do here is plug in -2. So we're going to be putting things into the x spot. So 2 raised to the -2 power. 2 to the -2 power makes 1/4. Okay. We can do calculations like this on our calculator. Let me show you. We're going to take 2 to the power of -2. And that gives us 0.25, or I can fraction that up and say 1/4. Alright, let's keep plugging in our x's. The next number is -1. What's 2 to the -1 power? Can you guys type that in and find the fraction? The fraction is going to be 1/2. This next number, let's plug in a 0. Oh, that's easy. 2 to the 0 power always makes a 1. A first power, 2 to the first power just makes a 2. 2 squared makes a 4. Things are doubling. because that number is a 2. All right, let's go ahead and graph this on our graph paper. So the points that we're graphing, -2, 1/4, -1, a half, 0, 1. We're going to graph all of these points, and we're going to see what shape we get. Does anybody know if this is going to be growth or decay? I don't know. Let's go find out. -2, 1/4, 1/4 of the box. -1 half, halfway up. 0, 1, right there on the line. 1, 2, 2, 4. Look at that. It's doubling, doubling, doubling. It's going to be approaching the x-axis, but never getting there. Use an arrow. And then it's going up, 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 up. Now, just since we stopped at the chart doesn't mean it stops. Make sure you put an arrow. It goes forever. So, class, was this growth or was this decay? Yes, this was exponential growth. Okay, the domain. What kind of numbers are you allowed to plug in? What kind of x's are being used? Domain is x's, range is y's. So the x's go as low as -infinity and as high as +infinity. Some students ask me, is that always going to be the answer for exponential graphs? Yes, you could always plug in all reals. Now, how about the range? The range numbers, there's no y's down here. All of the y's are more than 0. So that is an example of exponential growth. Okay, let's turn the page. The next example we have here is 1/2 to the x. And I want to see if you guys remember how to use your graphing calculators to take care of a chart. So there's a couple things we're going to do. We're going to go to y equals. If you have any of your plots on, go up there and hit enter, so they're all turned off. Delete any equations you might have in there, because the equation I want to type in is, maybe I'll do alpha y equals. I will do 1/2, and then to the power of x. There's your x button right there, right next to alpha, to the power of x. Okay, so I've got the equation typed in. Now we have to go to table setup, and that's in blue. So let's hit second, table setup, and you want to make sure that your independents, your x values, are asked, because I want to ask about these numbers. Okay, now I'm ready to go to my table, which is in blue, so make sure you hit second, table, and it seems like I have some numbers in here from before, so I'm just going to delete all those numbers out, because the numbers I want to ask about are -2, enter, -1, enter, 0, enter, 1, enter, 2, enter. Oh, so the numbers for my table are 4, 2, 1, 1/2, and 1/4. Okay, that was certainly fast, and you're going to see how the next equation is even faster. All right, let's go ahead and graph this. The points that we're working with, -2, 4, -1, 2, 0, 1, 1, 1/2, 2, 1/4. Let's go graph these points to see what kind of exponential graph we get. 2 to the left, 4 up. Starts way up there. -1, 2. Ooh, values are coming down. 0, 1. Getting smaller. 1 is half of a box. 2 is 1/4 of a box. Wow. Okay, so yeah, I use an arrow. The graph is getting smaller, smaller, smaller. Does anybody know what half of really, really tiny is? Really, really, really tiny, but it never makes a 0, so don't ever touch the x-axis. Just use an arrow. Get closer, closer, but never touch. That's called asymptotic. All right, how about the domain? What kind of x values can you plug in? X values? Well, all reals, from -infinity all the way up to +infinity. How about the range? What kind of y numbers are being used? Here's the y-axis. Was there any y's down here? No, they were all up there. The y's are all greater than 0. Was this growth or decay? The values were going down, down, down. So this was decay, D for down. It was decaying away, getting closer and closer, almost like nothing. All right. The next equation, negative 2 to the x. Does that negative power, is that negative getting the power of x? Or does x only belong to the 2? Yeah, you're right, it only belongs to the 2. The negative is out in front. Now I'm going to use the table feature again, except I have to go to y equals, and I have to change the equation to be the right one. Negative 2, I'm not going to use parentheses. I'm going to type it just like it is, and I'm going to give the exponent x just to the 2. Okay, make sure you type it just the way it's meant to be typed. Now when you go second table, the values, negative 2 through 2, are still there, and the new y values are there. Negative 0.25. Does anyone know what fraction that is? If you're not sure, you could always quit out of here. Negative 0.25, we can math fraction it up. Yeah, you were right, negative 1/4. So the table values are negative 1/4. Negative 0.5 is negative 1/2. 0 gets, negative 1. Look at that, because there was a negative sign. Negative 2, negative 4. So we have some negatives here. Okay, let's go graph these points. Negative 2, negative 1/4 is right there. Negative 1, negative 1/2 get to the middle of the box. 0 is at negative 1. 1's at negative 2. 2's at negative 4. So the numbers are getting smaller, smaller, smaller this way. But it's never going to touch the x-axis, so just use an arrow. Don't touch. And here it gets bigger, bigger, bigger with an arrow. Don't forget the arrows. Should we write that down? Let's write a little note. Don't forget the arrows. Okay, don't forget the arrows. Just because we stopped at negative 2 or 2 doesn't mean you can't plug in 3, 4, 5 if you'd like. You can keep going. The domain, what numbers are being used? From negative infinity all the way up to infinity for x's. Range is the y's. So take a look at this graph, because the y's are all down there. They're not more than 0. They are all less than 0. Should I say less than or equal? Does it ever touch the x-axis? No, don't say equal. So is this growth or is this decay? Yeah, this is decay. The values are going down, down, down. Okay, we've got one more, and this time we have a coefficient in front. A coefficient, then the base is 2 and the exponent is x. So let's use our table feature once again, and we're going to have to make sure we type this correctly. Maybe I will just delete that negative sign and insert the fraction 1/2. So let's make sure you get 1/2 times 2 to the x in your y equals. If you need to pause the video and ask a neighbor for help, go ahead and do that. Okay, now we're going to go to our table. And 0.125. Can you please exit out and find out what fraction 0.125 is? Did you guys figure out that the fraction is 1/8? Nicely done. How about 0.25? That's the number 1 out of 4. 1/2 is a half, and then we have 1, then we have 2. Before I even draw the graph, I want you guys to look at this equation, and I want you to examine the base. That's a 2. So can you tell me, without even seeing a graph, is that going to be growth or is that going to be decay if the base is 2? Yes, it's going to be growth. All right, let's go draw a nice graph. Negative 2 is at 1/8, get real tiny. Negative 1 is at 1/4, also tiny, but try not to get to half, because 0 needs a half. 1 gets a 1, and 2 gets a 2. Okay, it's a little shorter. It doesn't grow quite as fast. It's half as fast as the other one. Also gets an arrow. Domain for the last time is going to be negative infinity all the way up to positive infinity. All the real numbers for x. How about y? Does y use all the numbers? Nope, he only uses numbers that are greater than 0. Okay, so to recap, let me just tell you guys. y equals a, then you've got a base to the x power. I'm going to write it 2 times. Y equals a base to the x power. If you have a base in here that is base more than 1, is that going to be growth or decay? That's going to be growth. And then over here in this example, if you have a base that is less than 1, like a half or a fourth, that's going to be decay. And now it's time for a little quiz. I want you to pause the video and answer these 4 questions right here. Don't worry about the coefficient. Just examine the bases and decide if it's going to be growth or decay. After you put your guesses, replay the video. Okay, for number 1, I hope you said growth. For number 2, I hope you said decay. For number 3, I hope you said decay, because 0.2 is less than 1. And number 4 is 1.1, which is more than 1, so I hope that you said growth. Good job, class. I will see you tomorrow. Make sure everybody does all their homework so we are ready to go. Good luck.